this is Dr. Zheng from iDotSmart channel. From today, I'm going to create a set of the video clips introducing deep learning CNN. There will be two parts, concept and applications. In part one, I will cover the introduction, some of the concept like convolution, pooling, loss functions, and back propagation, also the gradient descent. And I'm also going to introduce you the CNN architecture and how to train a CNN. Let's look at today's part and a brief introduction. So here is an overview of the CNN concept applications. Okay, so when we talk about the convolutional neural network or deep learning, and so there's some of the related word like image processing, machine learning, computation, AI, and neuroscience. We will look at about the kind of the scope of this concept and a little later. So there's we need some hardware and software to, if we want to do the experiments or do some lab. So NVIDIA RTX 3080 is popular, afford GPU board. However, it's hard to acquire it right now. And software, we typically use the Linux operating system, use Python programming. And there are two major frameworks, and TensorFlow and PyTorch. And Jupyter Notebook or Lab is a very useful tool for as an interactive IDE. So when we do deep learning, we also need thousands of the data, big data. Typically, you need about thousands, millions of the labeled samples. The concept, I'm going to introduce it in this video section, and will be include the convolution, loss function, optimization, and normalization. So what is deep learning actually do? And say we use that for the pattern recognition, somehow like human vision, robot vision, computer vision. So we will have one more slice, also showing the scope and our interaction of this kind of concept. And what is the current progress we have? We have achieved, pretty much in facial recognition, image classification, and the speech recognition, and also like the machine translation, and some part of the, pretty big progress in autonomous car driving, and like Tesla is doing. Okay, so all these tasks we we have done some of the progress before in all this area, but what's the difference? The deep learning CNN can achieve a very high accuracy compared to previous method. Okay, so if you say deep learning CNN, it is very useful. So why it is just started right now is really depend on a lot of the, let's say, hardware, software, and also the big data. So we don't have such a sort of the situation or conditions, can satisfy the needs about deep learning. Okay? And the deep learning really, I thought that it started from year 2012. Let's say become popular in the year of 2012, and AlexNet, really won competition in image classification, competition. So talk about neural network it is a old concept. Okay, we also talked about artificial intelligence before. Okay, but really until quite recently, let's say year 2012, and deep learning or convolutional neural network bring attentions to everyone because they are excellent state of art, performance. So of course we also heard about the AlphaGo and the BERT, that's language Google language model. So we have the, let's say, simple neural network as shown from left, at left. And then you have one called hidden layer. You have input layer, output layer. And for this model, you have a file input and 4 output. So deep learning neural network, you have more layers, okay, more hidden layers. So we know this kind of structure. If we put more hidden layers, and so neural network performance, should be better. We know this kind of theory before. Now, this problem that before, let's say before the year 2000, we really don't have the big data. We really don't have the powerful computational hardware support such an application. Of course, also for deep learning neural network, there's a bunch of other concept and algorithm we need and to do the training and testing. So let's look at a little bit of history about computer vision and image classification. Now, human can do all the classification recognition. We need to, evaluate if a new, category, new object we want to recognize. We need to evaluate a few samples, but the machine, however, need thousands or even more. Okay, the computer vision. So when we talk about computer vision, and it is sort of like we need to utilize the knowledge from different subjects, and we mentioned here about needed the support from mathematics, engineering, physics, biology, psychology, computer science, and we try to solve sort of problem like pattern recognition, image analysis. We try to implement some of the automated process. This figure tried to illustrate the scope of different terms. Let's see here, we mentioned about convolutional neural network, we mentioned about deep learning, machine learning, and artificial intelligence. We see artificial intelligence is more broad and convolutional neural network more specific. Talk about if you have input, as images, for example, image classification, we should use convolutional neural network. Okay, so what we could for the computer vision, the task we put here, like object detection, classification. So we will probably have more sense about all this concept when we go over all this basic concept and do a few of the lab or specific applications. The ImageNet classification. So that is, way probably most of us heard about ImageNet classification. That's from year 2012, and there's AlexNet until let's see here about 84% of accuracy. That's 16% of the error. That is top 5 matches. Okay, so since year 2012, and that's a deep learning or convolutional neural network is developed very quickly. So 5 years later, at the year of the 2017, the accuracy of the convolutional neural network can achieve as high as 98%. That is, in general, that is even better than a human. Okay, because when we do the classification, now what's the problem for human? It is really we need to fight with the fatigue, and we get tired of if we keep looking at the same things, read thousands of images, we will get tired of it. Okay, let's talk about image. Let's say talk about image classification. So if you nowadays we talk about image is a digital image. So what is a digital image? Is a two-dimensional array. For a grayscale image, it's a two-dimensional array, and there is for a color image, we can see the three-dimensional array. That is, you have you have the you can see these rows, columns, or you also can see this is height and width, and you also have RGB 3 channels. Okay, this array, each of elements is a number that we refer as a pixel value. You know, it's between 0 to 225. Sorry, between 0 and 255. So so if the same object, right, and same target, so if we take the picture from different angles, the picture will look different. The pixel values will be different. So not just that, if we try to classify image recognized object, it's more challenging. So we could have different background, very complicated background. It could be, the image could be occluded by some other object, or maybe have appear a different of the brightness. So here are sort of the variation talk about illumination. Okay, so it's appear could be dark, you know, bright, and it could be, the image could be looks like closer in the further distance, far distance, and we here is talk about occlusion. Okay, so see some of the, you see this case on the right, you know, figure, and the cat is underneath sofa cushion. Okay, so also could be a different of the pose here called deformation, because appeared. So if there's a cat face to the camera or turn around different pose of the body, so all this for the image looks like different. Of course, we, you know, as human, we have a lot of experience, and we can probably evaluate, but for computation, it's going to be very challenging. And if you have, we all call them all cat, but they kind of, they have different types, different category of the cats. Okay. So how we can classify the cats, okay? So how we classify the different of the object, okay? Let's say for example, we have cat, dog, how are we to do the classification? So traditional methods, let's talk about image processing, image analysis. So we try to extract some features from the image. So for example, we can extract edges. So this is an example about the edges of the, you know, of a cat. So we can just let's say use the edge as a feature to do the classification. There's one of the traditional way we could do it, okay? And for image classification, we also can use called nearest neighbor classifier. Okay, let's say if I have a cat, okay, this is our cat. So this is query data. You give me a cat. Okay. So this is on the right figure here. That's the gallery I stored in database. You know, you have another cat from probably from another camera, live camera, or from a database. So I can compare. So their distance, you know, a simple way to do the comparison, just do the subtraction, okay? The test image and minus the training image, okay? So you can think about training is an image in a gallery or standard image. So I calculate their pixel difference and take the absolute and summarize, come to, you know, one number. You see that if the number is smaller, that means these two images are closer, are more similar. So we think that probably it is a cat. Of course, this is not going to be a very good measure, you know. So talk about the distance. You really have the called Manhattan distance. Okay, calculate absolute difference, and then we have Euclidean distance. We calculate difference, square, sum, and then take the square root. We are all familiar with Euclidean distance. We also refer this as L1 and L2 distance. And what is k-nearest neighbor? So when we do the image classification, we try to start with training set. So we give them a set of image that's dog cat. Okay, so I want to do the prediction, give me a query image, and I compare the query with my pre-stored image, I want to predict this is a dog or cat. So what is k nearest neighbor? So for example, I gave you an example, say, if it's supposed to have dog or cat, so each of the category I can have 10 representative images. I have 10 dog pictures, 10 cat pictures. So give me a quarter image. I compare with all these 20 images. I choose whatever the closest distance or shortest distance. That is, I choose the 10 of shortest distance after comparison with 20 images. So if this 10 shortest distance images and 8 of them from the cat category, 2 of them from dog category, I think 80% of chance query image, it is a cat image, okay? So that is called k nearest neighbor. So if 8 of those, images from cat, we can say 80% chance of the query image and it be a cat, okay? So if you have 10 different categories, okay, so we could do this, similar calculation and comparison. Okay, here say that instead doing distance metric, we can change the calculation slightly differently. Okay, there's here we have the input image, we call this X. So let's say we select or we select predefined parameters called weights and another parameter called B bias. Okay, so we have the input image. Okay, we have weight parameters and bias parameters. We do the calculation Wx dot product plus the bias B, and then we have the result. Let's see an example. And such calculation you could find it from the fully connected layers in the singing model such as AlexNet. Here, give you an example. So suppose our image is 2 by 2 pixel, very small, and if actual image is 32 by 32, 800 by 600, same things. We just give you illustrate here the 2 by 2 pixel image. So we have a weight here. So this is the weight. You can say predefined parameters, or actually this is parameters. We will get that parameters through the training. Okay, so we have weight, I have a bias. Okay, so we have 4 pixels. Obvious that so this dimension of the weight that also has to correspond to number of pixels you try to calculate, try to manipulate. Don't have to be the image size. We will learn these details in the next lecture. Okay. So we have those weight parameters. We have the image pixels. We do the calculation. Here it is matrix, matrix product. So plus bias, we have these numbers. We call this a cat score, dog score, shape score, 3 different categories. You can see each of row that is a weight correspond to each sort of category. So you give me the input image, okay, give me the weight, okay, the weight can be obtained through the training and the bias. So we can calculate scores, okay, for each of category. So we would think about whichever the category has the highest scores, that's more likely the query image belong to that category. Later on, we will develop this kind of concept to from the scores to the loss, to the loss calculation. How to classify the images, how to classify the images into different categories. If you only 2 categories, I really want to draw like a boundary and can separate the 2 different categories. So if you have multiple categories, I need several boundary lines so that I can distinguish one from another. Of course, this is just for sort of illustration. And if you have multiple classes, and quickly you will find this is kind of very difficult. You can draw a linear boundary to separate the different classes, different groups. And here give you an example about, for example, if you have two different classes and they are located in different quadrants, and that's hard to draw one line, as a boundary. Same thing if you have one class on the ring, other class outside the ring, that's also going to be hard, to draw a linear boundary. And a similar situation for, on the right figure. Okay, so this chapter, this section just gave you actually gave you a brief introduction about deep learning and convolutional neural network. So mainly try to give you a background about what is the connection between deep learning, convolutional neural network, and computer vision. So next lectures, I'm going to introduce you about the basic concept, convolution pooling, and loss function. And if you want to know more about this video series, please visit our subscribe YouTube channel, iDotSmart. And this is Dr. Zheng. And today is last day of the year 2021. Happy New Year to everybody. Thank you.